Good evening once again. We are here to continue with our class, Ugbs 302 research method. So today we said we will be sending the one sample population analysis to a two sample study. So we are going to test for two populations. So the previous videos we were testing for only one population. So this time around we are going to pick two populations and test with this method. Okay. So with this hypothesis for two samples, I think hypothesis on difference between two populations means using bivariate paired data. Hypothesis on difference between two populations means using independent samples. Then we draw our conclusions. So I want to write something here. Okay, so with these two samples, we are having two. So hypothesis for two samples. So we are having two types. And today we are going to tackle with one of them. All right, so the first one we have independent sample. Independent samples. So with this sample, we are saying is when the samples are drawn from two different populations. So we take two different populations and you draw your sample from it. You get it? So it's when samples are drawn from two different populations. So let's say you want to test for a particular claim between two different populations. So you can say accounting student in Eugene, that's like one, and accounting student in, let's say, UCC, you get it. So you want to test for a particular claim, you want to test for a particular assumption. So you pick the samples you are going to pick. So you are going to pick sample from Legon, you get it. Let's say 10 students or something, 15 students from Legon, University of Ghana, accounting students. And also you pick 10 students from UCC, accounting students, and you test for your claim. You get it. So that's why you call the independent samples. You also have dependent or paired samples. Dependent or paired samples. And with these samples, we are saying it's when the samples are drawn from the same population but being tested for different activities. You get it. So with this one, is when the samples are drawn from same population being tested for the same. Sorry. Okay. So these are types we have on our two samples. So we have independent samples and dependent. So with the dependent or paired samples, you will pick the samples from the same population. So if you come to Eugene and you are picking accounting students, you will pick the samples from Eugene, but for different activities. And normally with this dependent or paired samples, it comes in the form of before and after. Before and after. Before and after. You get it. So let's say there's a claim that after working out for 30 days or after working out for 15 days, you reduce weight. So you pick the sample from the same population. You get it. You pick the sample from the same population, and you test for you pick the sample from the same population before the activity, that is before the workout. and you also pick the sample, the same sample from the same population, but this time around it will be the after. You get it? So normally it comes in before and after forms. So if you see a question and it is before and after, just bear in mind that these are dependent or paired samples. You get this one, the sample, with this one, the samples are drawn from the same population but being tested for different activities. So let's say you pick the sample, you check the before and after, and you test whether the assumption or the claim that when you work out for 15 days, you reduce your weight or something. You get it? And it usually comes in the form of before and after. So when you see before and after questions, bear in mind it's what? Dependent. Okay.
Dependent. Okay.
I hope it's clear now.
Yes, please, it's clear.
So let's move on to. So today we'll be tackling this one, the dependent or paired
sample.
Okay. So as I said, it is used to test the differences between two populations, or it is used to test the differences between population means using two related or paired or matched before and after samples. Okay, so let me try this one. Okay, so that's the mean. And we are seeing the population mean is the population difference is UD. We'll go to that one. I'll use the slide to explain that one. So we are seeing the assumptions on this. So we are seeing that data or differences, the difference that's the mu D between paired values are normally distributed. You get it? So difference or the mu D. So difference or mu D, mu, then you write D, I think that one is subscript, yes. Between with this one, they are normally distributed because it's a parametric test. I'll use the slide to explain that one. Okay. So,
okay.
Any question before I move on?
No question, please.
As I said, we will be doing the before and after. That's the dependent one today. And the next session, you will do the independent. Okay, so this is what we are trying to say. The paired or dependent samples. So we are saying it is used to test. So this one, when you see before and after, whenever a question is given to you and you see it's before and after, bear in mind there are two samples drawn from the same population. And you are going to use the steps we are about to follow to test for that particular claim. You get it? So I said it comes in a form of what? Before and after. So before and what? After. And with their means, we represent before with what? Mu B. Sorry, I'm using a mouse. So
okay.
So mu, and the mu after 2 is what? Mu A. Now with this one, stating your null and alternative hypothesis will be difficult if you don't use this mu B and mu A, because at times you get a question and you know know how to formulate your hypothesis. You get it? It's not like the one population, the one sample, the one we did the other time. You see that one, you see some words. You get it? Particular words will link you to know whether this one is what talking about
the null or the alternative,
and it will guide you to know whether this one is what one-tailed test or two-tailed test. But with this one, you have to use the before and after. So we represent the before, the mu with what? Mu B, and the after with what? Mu A. You get it?
Yes, please.
So you identify the relationship between the before and after. That's the mu B and mu A. Then you use that sign. That sign will lead you to what? Or will help you to formulate your hypothesis for the same question. So let's take an example. When you see this word effective, let's say I want to read a particular question. I'm coming. I want to.
Okay.
Let me pick it from the slides. So we have a particular question here. We are seeing that here is, let me use, can you see the slide?
Yes, please. I can see it.
Okay. So you see this particular example, example one. I think a group of reputable firms in Ghana claim that the mean price of residential homes before, so you see that this one before is here, and already the before and after will be given to you in a table, tabular form like this. So a group of reputable firms in Ghana claim that the mean price of residential homes before the change of government does not exceed the mean price after the new government in Ghana came to power. So this one is talking about what? Before and after. And it's talking about the mean price of residential homes. So they are trying to say that before the change of government, there were certain prices, and after the change of government, there were also at certain prices. So the claim is saying that the price before the change of government does not exceed. So the mu B is the before, and the mu A will be the after here. So with this one, when you are formulating the relationship between this, so always use the B first, all right? Always use the B, mu B, then you have what? Mu A here. So with this one, if they are saying does not exceed, what can you say about this one? Hello?
So what? Yeah, can you hear me?
So with the, what's the relationship between the mu before and the mu after? What's the relationship?
I will say the before is less than the after, since it does not exceed it.
Does not exceed.
Yeah.
So it is what? Less than. Now, with this word, does not exceed. Does not exceed. Which sign does it relate to?
So it could be equal. It could be equal or less. So it should be less than or equal to.
Good. And less than or equal to is in which hypothesis?
It's in the null hypothesis.
Good, it's in the null hypothesis. So this one, they are saying that reputable firms in Ghana claim that the mean price of residential homes before the change of government does not exceed, this is the word, does not exceed the mean price. So the before here does not. So the before does not exceed the mean price what after. So UB is less than or equal to, if it does not exceed, it could be equal to or what? Less. If you are given 100 cedis and you are being told, you can't spend more than this 100 cedis, is either you use equal to this 100 or use what? Less of this 100 cedis. You get it?
Yes, please.
So after using the before and after to formulate, to know the sign, then you move on to use UD, because always it will start with UD. So HO is such that. So with the relationship here, it's for null hypothesis, right? And
Yes.
Good. So when you see the sign like this, the next step is just state HO and HA. Use the sign for, the sign will be for what? HA, right? HO. And what is the opposite of what? Less than or equal to?
Greater than.
Greater than. Good. So after formulating it, so always it will be UD, because the difference between the after and before is always what? UD. It's always UD. So it will be like this. So mu D is the difference, the mean difference. First one is saying that it's less than or equal to what? Then here you bring 0, because we are saying UD is always 0. Then HE, we are saying UD is greater than 0. So you see, when you use the mu before and the mu after, you easily identify your sign, that's less than or greater than. But if you don't use this one and you want to formulate the HO and HA straightforward, you find yourself wanting to get it. How are you going to know the sign does not exceed?
Oh, okay.
Someone can pick the question and say that, oh, does not exceed is less than or equal to. And less than or is equal to is in what? Null hypothesis. You get it? Because they contain the equality signs. So they will just know that HO is such that UD. So always with the two samples, we start with the UD for the dependent, the paired samples. So UD, then he or she knows that this one does not exceed less than or equal to. So less than or equal to 0. Then the HA will always challenges what? The HO. So that will be what? Greater than the same HD. And the UD is always 0. The mu for UD is always 0. So bear in mind, the mu D is always 0. So do you have a question?
No, we can continue.
Okay. So as I said, UD is always 0. Bear in mind. All right. So as I said, so this is what I typed on the board. So that's the difference, population difference. That's what I was talking about, UD. This UD here is always 0. It's always equal to 0. Take note. An assumption, data are different, that the mu D between paired values are normally distributed. Right. So let's look at the types of hypothesis for mean of population of difference. So as we know, HO contains what? The equality sign. So it's either UD. So as I said, the dependent or paired samples, always when you are starting the null and alternate, it should be, the mu should be what? UD. That's the mu D. So with the HO, the null, we have the equal sign, less than or equal to, and what? Greater than or equal to. Because the null hypothesis, we've learned this one. They are saying it contains the equality sign. So now that's the HO, they contain equal to, less than or equal to, greater than or equal to. Then is the HA. The HA always challenges one, the HO. If you are saying right, if HO is saying right, HA will say left.
Left.
So HA does not contain the equality sign. So if HO is saying is equal to HA will be what? Not equal to.
Not equal to.
If HO is saying less than or equal to, HA will say greater than. If HO is saying greater than or equal to, HO will say less than. So with a type of test, we know how to determine if this one is one-sided or two-sided. So when you see equal sign and not equal to, it's what? Two-sided.
Sided.
And the rest are one-sided. Okay.
Two-sided.
Yes. And with how to find the degrees of freedom, they are the same. How to find your T tabulated or T critical. You get it?
Okay, yes,
They are the same. For you to get your T critical or your T tabulated, with the one sample, you see, you have your T n minus 1. So you find that one, your population minus 1, population size minus 1. You match it with what? The alpha.
Alpha.
Then you find what? T critical value. And I said with the alpha, the table they provided under research methods. When you see, after formulating your hypothesis, and you see that it's two-sided, in quantitative methods, that's last semester, we learned that when you see that hypothesis, so if this one is equal to, and your alpha is 0.05, we were told to divide alpha by 2 so that you get to 0.025 if it is two-sided. But with this, the table under research methods, they've done a column for, how do you say it? They've done a column. Yes, so they already can see the table here. I'm coming. So the table is here. You see that we have one tail here and two tails, one tail, two tails. So with this one, even if after formulating your hypothesis and you see that that one is two-sided, and you are seeing your alpha to be 0.05, when you are reading your T critical, do not divide the alpha by 2. I repeat, do not divide your alpha by 2.
Okay.
The same method to find a T critical. You match.
It will be if it.
Yes, yeah.
So if it's 0.05, you should use the 0.05.
Yes, because there's a column for two tails in the table, so you don't have to divide it. Okay. With the degrees of freedom, you subtract 1 from the sample size. You match it with the alpha value. That will help you get your what? T critical, right?
Yeah. Okay.
And we have a different formula for finding T computed. You get it? T computed. So as you can see down here, it is T is equal to D bar. The D bar is minus UD. It's minus UD. But I told you that always the UD is equal to 0. So it is D bar minus 0. So it will be D bar minus mu D all over the denominator, that is SD over N. But I told you UD is always 0. So it will be D bar only.
Okay.
So that's what it means. So we are trying to say that the T calculated, for you to find the T calculated. So here, all the work, you will do the work here, the T calculated. That's where you do a lot of workings, a lot of calculations. So the finding T critical is not a problem. Stating your null and alternative with the method I've taught you using the mu before and mu after, you shouldn't find it difficult. But with finding the T calculated or T calc, yes, or T computed, you have to do a lot of working. So we are saying is D bar all over SD minus all over square root of N. And before you get SD2, standard deviation will not be given. Because in the one sample, we were giving what? SD, standard deviation. But here you'll not be giving standard deviation. So we are saying the standard deviation is equal to SD is equal to what? Sigma to bracket. The sigma is summation. Sigma D minus 1, D bar all squared, all over at n minus n. All of
minus
them minus 1, n minus 1. All of them square roots. That'll help you get what? The SD.
standard deviation.
Yes. And for you to get the d bar here, and the d bar here, it is the summation of di. Di is your difference. I'll teach you how to find the difference too. All over at n. That will help you get your d bar. And your di, for you to find your di, it's like you see every question you'll be given what before and after. So it's after minus what before, a minus b.
After minus before.
Don't confuse yourself saying before or after. Just say a minus b. That will help you record that it is what after minus before. That will help you get the di.
Okay.
Yeah, so you add all the d you worked for, divided at sample size. That will help you get d bar. After getting d bar, you use d bar to work for d minus d bar. Then you square it before you use it to find what SD. So when you solve for SD, when you solve for d bar, you are good to go to find your t computed. So the t computed we are saying is it's equal to t is equal to d bar all over what SD over square root of what n. Now help us get our t calculated or t computed, and we also have our t critical. That one we know how to solve it. If this one, if you match it with what alpha. Then you compare the two, you make your decisions. Making the decision, we have the same two approaches. So you can use the critical value approach or the p-value approach. The decision rule is the same. Everything is the same. You get it? With the exception of the t calculated. That's where you do a lot of solvents, calculations. Apart from that, everything is same as what you've done already. Okay, so any question before I move on?
No, please, you can carry on.
So what's the decision rule for the critical value approach?
So, Pa,
Yes, yeah.
the decision rule is when the thing falls in the region, falls in the critical region or the alpha region, you reject.
Most of the times with this research method, you don't draw curve. So
okay.
the decision will be
equal sign.
You compare the calculated and what t critical. When we are having two approaches in deciding critical value approach and p-value approach. So with the critical value approach, you will reject HO if t calculated is greater than what t critical. Reject HO if t calculated is greater than t critical. Otherwise, what fail to reject. And with the p-value approach, reject HO if p-value is less than alpha. So with the critical value approach, you are comparing calculated and what critical. P-value, you are comparing what? P-value approach, you are comparing p-value and what? Alpha value. The alpha will be given in the question, level of significance. But how do you find your p? So I said you always use the t computed what we solved here, the t computed. Whatever we solved here, we use that one to find our p-value. So the p-value is the probability of this t. You find it from the table. You get it? All right. So that's the rule. So as I said, this is how we find the G bar. And let's do the sample standard deviation of differences. And as you already know, the sample size. So this is the rule. Reject HO if p value is less than alpha. That's the p value approach. And the second one is saying reject each row if T calculated is greater than T calculated. T calculated is what T computed. T tabulated is a T critical. So this is talking about the p-value approach. The second one is talking about critical value approach. Let's forget about the third one on that. Okay. So I'm having a particular table here I want us to discuss. Okay. Oh, sorry, I think I skipped this. So we are having parametric test and what non-parametric test. So they were saying that this table normally comes in exams as objectives, and it's really important for you to learn it offhand. You get it? So the one sample t test, the one we did the other time, it's analog for non-parametric test is what? Binomial. Because we said the one sample test must be normally distributed. So if this one is normally distributed, or the one sample t test, this is a parametric test. And the non-parametric test for one sample t test for one binomial. Per t test, what you've been doing now. The non-parametric is what? Recursion sign rank test or McNeman's chi-square test. And we have independent t test. Hope you recall that earlier this class I said we have two types of
dependent and independent.
Independent and dependent. So the independent t test for parametric test, its non-parametric test is what? Whitney U or recursion rank sum test. We have that one for correlation. Pearson's correlation. We have Spearman's correlation. So we have to get these things off-head. It's really important. So you have to learn them. So we will tackle with what? The paired, they are the same. You get it? The paired t test. That's the independent. And their non-parametric test is either recursion sign rank test or McNeman's chi-square. So this is where we are going to focus. Our focus is today. Where we focus today. Then the next session we will learn the independent test. It's non-parametric. We will not learn the parametric test. That's the independent. You will learn the non-parametric test. That's the man, Whitney, you or real rank sum test. Recursion. So, do you have any question before I move on to tutorial set? We have some examples here under the paired or dependent samples. Okay. So read the first question for me. So we are about to solve the question 1, 2, and 3. Then we are done. Okay. So read the question for me.
So question 1. A group of reputable firms in Ghana claim that the mean of residential homes before change of government does not exceed the mean price after the new government in Ghana came to power. Toneton.com in Ghana, wishing to determine the authenticity of this claim, selected a sample of residential properties to appraise their prices before and after the change of government. The results reported in Ghana 00 are as follows.
Okay. Okay, continue. The question at the 0.01 significance level.
Okay, at the 0.01 significance level, A, state the null hypothesis and alternate hypothesis. B, what is the critical value of the test statistic? C, what is the calculated value of the test statistic? D, make your decision using the critical value approach. E, what is the p-value? Decide with it. F, mention one assumption that needs to be made about the distribution of the differences. G, Is the change of government associated with the higher prices of residential homes justified practically?
Okay, so I think we've already formulated the hypothesis for this one, but for the purpose of the class, let me. Okay. Let me copy this. Please write down the before and after. So when I'm writing, you give it to me. Hello.
Okay, I'm doing that. I'm done. I'm done.
Okay. So the first question was like state the null and alternate hypothesis. So with this one, as I said, you first of all compare the relationship between what the mu d and the mu a. You get it? So mu always start with the mu b because it will be before and after. Before comes first, then after will follow. The mu a, write it well. The mu and you are doing it. Okay. So with this one, what's the relationship between? Because they are saying that the mean price of residential homes before the change of government does not exceed the mean price after. So how does this mean? What's the relationship between the mean before and the after?
So the mean before is less than or equal to the mean after.
Okay. So always you take it this way, you not find yourself wanting. And I said after doing this, after identifying the sign, you just move on to formulate your HO and what? HO and what? H A. The HO is such that, and always it's what UD, the population mean difference. Population difference. Always. This one is also mu d. So with this one, you are saying, then when you see this sign, less than or equal to, we know that is what? Null hypothesis. And this one to what? Greater than. So if this one is less than or equal to, and I've told you the UD always is 0, right? So UD is 0 here. Their mu is always 0. The mean is always 0 for UD. So this is how you formulate your, but if you are about to use or state the hypothesis straightforward, maybe in some questions you get to know it's simple, but in other questions too, when you don't use this approach, find the relationship between before and after, you find yourself wanting, because this one, you see the word does not, the before does not exceed the mean price after, and you know that does not exceed is what? Less than or equal to. So straightforward, you can see that HO is such that UD is less than or equal to 0. And this one, less than or equal to, is what? Null hypothesis. Then the alternative was greater than. You are done formulating your hypothesis. What was the second question, sir? The second question was asking us to solve T critical, right? So T critical. So with this one, as I told you, we know it's degrees of freedom, comma, your alpha, right? You match them and you find out from the graph. So what is our degrees of freedom in this question? Now with the paired samples, it's talking about two samples, but this one was picked from the same population. So the degrees of freedom is still n minus 1. But for independence, we are testing for two populations. So that one, it is n minus 1 and another n minus 1. So when you add it, you get n1 plus n2 minus 2. That's the independent. So forget about that one. But this one, we are dealing with paired or dependent. So it's still n minus 1. And your alpha will be here. You get it. Okay. So what will be the n minus 1? N minus 1 will be.
So our n minus 1 will be, you count the sample size, then subtract 1 from it.
Okay, so it will be.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10. So it's 10 minus 1.
9. Then the level of significance was 0.01, right? From the question. Yeah. Can you see the level of significance at 0.01 level of significance here?
Yes, please.
Okay. We are going to match the two. We are going to use the two. That's the 9 and 0.01 to find our T critical. So let's move straight to the table. Here's the table. So, and this one, less than or equal to, is it 1 tail or 2 tail test?
Empire is 1 tail.
Yeah, so we have a column for 1 tail here. You have, yes, you see 1 tail here. 1 tail. That's why I told you shouldn't bother about the alpha when it is 2-tailed. You don't worry yourself to divide it because you've already done that here, 2-tailed test. You have 1 tail. So this is 9, and you are looking for what? 0.01 on the 1 tail. You get it? The 0.01, 1 tail is here. But I see the 0.01 having 2. This one is for 2 tail. But this particular hypothesis is 1 tail test. So the 0.01, you match it with what? 9. So where did you meet? Here. If you can see, let me zoom in. It's 0.01 on the 1 tail. What is this one? Then you match it with what? 9. Where did you meet?
So
Here, right?
1.833.
Is that
1.833.
look at it? 0.01 is here.
Okay, 0.01. You said 0.01.
Here.
Okay.
This 1 tail test.
Okay.
You match it with 9 degrees of freedom. So where they meet is here, 2.821.
2.821. Okay.
So our T critical is 2.821. 0.321. And the third question is asking for what? T calculated or T tabulated. So T calculated or T calc. T. So this one, this is where the workload is. So with this one, we are saying it is D bar all over SD square root of n. That's the formula. So now let's find our G bar first. You get it?
Yes.
So this way I need the info. So start with after so that when you are subtracted, it won't be anything difficult to you than before. Then you get your what? D here. DI. Okay. So leave the after for me.
Okay, so 135, 110, 131, 142, 105, 130, 131, 110, 125, and 149.
Okay. Leave the before.
So 128.
So 128, let's go.
105, 119, 140, 98, 123, 127, 115, 122, and 145.
Okay. So let's see this after, let's represent it with 2. And let's represent it before with what? 1. So the difference here is what? 2 minus 1. So after minus before. So represented after with 2, before with 1. So it is before, after minus before, A minus B. So A minus 1. B will help us get what? Our D. Okay, so let's list our D2 by subtracting after, before from after. So 135 minus 120 to give us
7.
Okay, so 110 minus 105. So work them and
5.
5. I think this one to be
12.
Okay.
2.
7.
4. Negative 5. Oh no, per wait. So after clean the 4 is 7 again. 7. Then you come 4. Negative 5. 3.
Is 3,
I said
right?
3 and 4.
Okay. So you find your D bar. You find your D bar. Sigma DI. All right. So add all the D's. If
You
they are
get
minus,
46.
you get
46.
46. Okay. Now you know our D bar. And the T calculated was saying that is D bar all over SD all over square root of n. Now we don't know the SD, and SD2 we said is giving us summation square root of this. sigma di minus d bar all squared all over. Okay, so we have to create a column for d minus d bar, then another column for d minus d bar squared. So it is d minus d bar, and also d minus d bar again, but this time around all squared. So d minus d bar and d minus d bar, you square whatever I get here. So let's start. D minus d bar, so we are going to do them. So this d minus the d bar here. So start giving the answers.
So, but the first one is negative 39.
Sorry. The d bar, we didn't finish. It
Okay, yeah.
N. You get it. So it will what? 4.6, right?
4.6. Okay.
Yes. So let's move on. So this d minus this 4.6. So
the first one is 2.4.
2.4. Square it and let me see.
Okay. 2.4. Yes. That's good. You get 5.76.
Okay, so that will be for this one. Okay, so let's move on.
So the next one is 0.4.
Right.
You get 0.16.
Okay, do for the next one.
7.4.
Right.
54.76. 0.76. Okay.
Next one.
Negative 2.6.
Negative 2.6. Okay. Square it.
6.76. So I think the 7.2 will be the same as the first one.
Oh, okay. So it's 2.4 and 5.76. Same for this. 2.4.
So the next one you get negative 0.6.
Negative 0.6. Square it.
When you square, you get 0.36.
Negative 5.
So negative 5 minus 6. You get negative 9.6.
Square it.
92.16.
Okay. Right.
So negative 1.6.
Right.
2.56. And the next one, 4, you get negative 0.6. When you square it, you get 0.36. 0.36.
So what to do the sigma?
Okay, so 5, 7.
What do the final of this, the last column?
I'm coming. So I got 174.4.
174.4. So I'm moving on with the SD. So it will equal to all square root. So it is 174.4. All over 10 minus 1. So 10 minus 1. So just give me the final answer.
So you get 4.40.
4.40. All right. So I'm moving on to what? I'm going to solve. We are still solving the T calculated. So you see, I told you the workload is here. Get it? The workload is T calculated. Another dependence of per samples. This is where the workload is T calculated. I'm seeing is the formula is here. D bar. So what is D bar?
So D bar is 4.6.
4.6. SD is what? 4.40. Right?
4.40. Yeah.
Over square root of 10. So over square root of 10. Right?
10. Yeah.
What will be the final answer?
So you will get 3.30, like 3.306. So I don't know if you run it up.
Because this is in 3 decimal place, secret card in 3 decimal. Let's leave this one to in 3 decimal place.
Oh, okay. Okay.
This is your
3.306.
Okay. All right. What next? The question again. So C is the what is the, so we've solved C now. Now D, we are saying we should make decision with the critical value approach. Okay. So this is C. Yes. This is D. This is what A. So with the D, I think you should make decision with what? Critical value approach. So critical value approach to compare T calculated, T cal and what? T critical, T crit, and T calc, so T calculated. Okay, so what is the value for T calculated? We got
3.306.
And T critical is what?
2.821.
Okay, so T calculated is greater than T critical, right?
Yes.
What will be the decision under this?
So you will reject HO.
Yes, the rule is saying reject HO. So we are rejecting HO since 0.306 is greater than T critical or T crit of 821. Okay, so this is the D. And let me see the E. The E is saying what is the P value? Decide with it. So we are moving on to p-value approach. So I told you the p-value to compare p-value and alpha, right?
Yes.
And I told you the p-value is the probability of what? The t calculated. So we know alpha to be, from the question, we know that alpha is 0.01, right? Now, how do you find the p-value? You go and search for the probability of what? 3.306 on the table. You get it?
Yes.
So we are looking at 3.306. So if you see it, just prompt me and trace it up there.
Oh, okay. 3.
We might not get the same number. So you find the same, let's say, number which is closer to 3.306.
I think I have found 3.307.
3.307.
Just scroll down.
Wait.
Scroll down.
Okay, yeah.
Yeah.
Okay, so 3.307, you trace it up. It's on this column. So are we choosing 0.001 or 0.002?
You'll be choosing 0.002.
Why?
You said with this one, you will not be dividing. Okay, since it's a one side thing, so it's a one tail test, so we'll be choosing 0.002.
0.00.
0.002 or
001. 1 or 2. Are you picking this one or this?
I'll pick the 2. 0.002.
Fine. This 0.002 here is for.
Oh, it's for 2 tails. Okay.
And this one it was not equal to or not equal to. It's just less than or equal to and greater than. So this is talking about what? One-sided or one-tilted.
Yeah.
So let's pick the 0.01. That's the answer.
0.01.
Yes.
Okay.
We trace it here. You do understand it?
Yes. Yes.
Okay. This one too is 0.001. And 0.001 and 0.01. Which one is greater than the other?
0.01 is greater than 0.001.
Greater than this, right?
Yeah.
So this is less than this. So if p-value is less than alpha, what will be the decision? What will be the decision?
You reject HO.
Yes, so if p-value is less than alpha, reject HO. So we are rejecting HO. Since p-value of 0.001 is less than alpha value of alpha of what? 0.001. So with this one, with the critical, let's add it at 5% level, 1% level of significance.
Okay.
Okay. So let's look at the F. So even if you use a p-value and what critical value approach, we are still ending at the same decision. What we are rejecting HO, right?
Yeah.
Now, the F. This is also another important part of the question. We are seeing mention, okay, the G is there. Mention one assumption that needs to be made about the distribution difference. So what's the distribution of differences? So this one we are talking about two-sided, and with the two-sided, we are saying they are normally what distributed. So that's the assumption. Just write that. One assumption is they are normally distributed.
Okay.
So the F is what? F should be must be normally distributed. Then G. G is what? G. Let me look at the question. G is saying is the change of government associated with the higher price of residential homes justify practically. So here they are asking if the change of government really affect or was the cause of higher price of residential homes. Here we are going to use your hypothesis that you formulated to answer that question. So with the HO, so this one HO was saying it does not exceed the higher, right? The before does not exceed the after, right?
The after. Yeah.
Right?
Yeah,
so here we are rejecting the null hypothesis. So what the null hypothesis is trying to tell us that the change of government, you get it? The before did not exceed the after.
Yeah, after.
So your conclusion would be like, no, because even before government was changed, prices were higher. That would be your conclusion. So this HO was telling us that the change of the government is the cause of higher prices. And the HA is saying that the change of government is not the cause of higher prices. So if we are rejecting HO which says that the change of government is the reason or the cause of higher prices, we are rejecting that HO. Then probably we are referring to HA, which says the change of government has nothing to do with what? The higher prices.
Okay.
So your answer will be no. So justify practical no. So it will be no. Because even before government was changed, before government prices were higher. All right, so this is how we answer a question for two samples within one population. That's the dependent samples or paired samples. So do you have any question before we move on? Do you have any question? Hello, do you have any question? So
Okay.
do you have any question?
No, please. You can continue.
So let's move on to another question. So read the question.
So
the question
okay. Tria is vice president for human resources for a large manufacturing company. In recent years, he has noticed an increase in absenteeism that he thinks is related to the general health of the employees. 4 years ago, In an attempt to improve the situation, he began a fitness program in which employees exercise during their lunch hour. To evaluate the program, he selected a random sample of participants and found the number of days each was absent. Below are the results. At 5% significance level, did the program reduce absenteeism? A. State the null hypothesis and alternate hypothesis. B. What is the critical value of the test statistic? C. What is the calculated value of the test statistic? D. Decide using the critical value approach. E. What is the p-value? Use it to decide. F. Did the fitness program reduce absenteeism at the 5% significance level? Conclude practically.
Yeah, it's basically the same questions. The same questions, yes. So state the null hypothesis. So this one, just know your mu before and mu after. That will help you to state your null and alternate. Because if you are to do it straightforward, you will suffer. Yes, bear in mind you suffer. So what is the relationship between our mu before and mu after?
So I think here we will use the notice an increase in absenteeism. So I think it will be greater than.
It will be what?
That's greater than.
The mu before will be greater than mu after.
Yeah.
So in other words, the mu after will be less than mu before, right?
Yes.
Yeah. So this is the example I made earlier. So I said he has noticed an increase in absenteeism. That thing is related to the general health of employees. So and the way because the person is not feeling well. In an attempt to improve the situation, in an attempt to solve this situation, he began a fitness program in which employees exercise during their lunch hour. You get it? So the claim is that when you do this exercise, you lose weight. So before, they were not doing any exercises during their lunch, but after the program, they began doing those exercises during their lunch. You get it?
Yes.
And we normally say if you do exercise, you reduce weight. So your before will be greater than your after. In other words, your after will be less than your before, right?
Yes.
So if your before, their weight before, you get it? Or the program, the program did not, the before is greater than the after. Always write before first and after second. Or before comes, then after follows. So a mu b. So mu b is greater than what? Mu a. He has noticed an increase in. So I attempt to improve the situation. He began a fitness program in which employees exercise during their lunch. You get it?
Yes.
So the relationship between mu b and mu a is that your after will be less than before. So when you are writing it before and after, it will be after. So this one here is the same as this. Mu a is less than or equal to what? Mu b. You get it? So with this one, don't focus on this part. You don't focus on this part. Focus here. So with this one, which sign is greater than what? Right? And it's containing which hypothesis?
Alternate.
Alternate. Good. So you just move straight your H over here. Your HA. Right. So I said after using the mu b and mu a to identify your sign, just use mu d and 0 to state your hypothesis. So ud is always ud and 0. Then you use your sign. ud is greater than what? 0. Then what will be the opposite?
ud is less than or equal to 0.
Good. And this is talking about untitled test. So let's move on to the whiteboard. Right. It's question 2. We are saying the null and hypothesis will be HO will be HA is mu D. Mu D. So this one is less than or equal to 0. This one is what? Greater than 0. Do you understand?
Yes.
So this, if our before will be greater than our after, then it means if the before, the situation reduced, the after implementing this program, the absenteeism reduced, then it's relating to HA. So the HA is trying to tell us that program reduced absenteeism. You get what I'm trying to say?
Yes, please. I get it.
Because they are saying that the workers were absenting themselves from work as a result of our general health issues. And the manager tried to implement a certain program where the workers will exercise during their lunch. And they are saying that to test whether the thing improve is greater than. When you're doing something and someone tell you that, oh, you have to improve in doing this, you have to improve in doing that, it means you must add more to it. So it's greater than what you are having or you were having already. So if after the mu b is greater than mu after a, so if before is better than after, then we are saying that the program reduced absenteeism because after doing the exercises, they were okay, they were coming to work. And this is the opposite. The HO is the opposite. The program did not reduce absenteeism. So now they were absenting themselves from work. So you have to understand whatever you formulated. Otherwise, the last part, that's the conclusion. You cannot give a better conclusion, right? And a B is saying we should find our T critical. And you know that our T critical is the degrees of freedom and our alpha. The degrees of freedom is n minus 1. Now, how many n's do we have here? How many n's do you have here? 1, 2, 3, 4, 5, 6, 7. How many n's do you have?
8.
8, right? Hello.
Yeah.
Okay, so we have how many n's? 8, right?
Yes.
So 8 minus 1 will be what? 7.
7.
And the degrees of freedom is here, 5% level of significance. The alpha value. The degrees of freedom is 7. 8 minus 1 which will be 7.
7.
Match it to what?
0.05.
With this one, you go and look for this on the graph from the table. Okay, so degrees of freedom is 7. Then which value are we looking for on top?
0.05.
0.05. We have 1
Yeah.
here. We have 1 here. Which one are you choosing? Is it this one? Is it the one with asterisk or the one with what? A small circle?
So the one with asterisk.
Yes, because that one is 1 till, because less than or is 1 till. So you match them wherever it meets with this one. So it meets here, right?
1.895. 895.
Exactly. So it's 1 point. Then we move to what? T critical T completed. The C is asking us to solve the value of what's the calculated value of the test statistic. That is talking about the T calculated. T calculated. So this one is where the workload is. So we know the formula to be what? D bar. What? SD. All over square root of what? N. And you know SD is
Square root
of
summation
or summation.
D minus D bar square all over N minus 1.
And the D bar itself is what?
Summation of DI all over N.
Let's compute for this. So after then G, then you solve your D minus D bar. Then you solve your D minus D bar all squared.
Can you go back so that I can write the values down?
Yeah,
Or the before and after?
Yeah, you have written it down. Let me punch, and after that we go and cross check. So the after I start with 5, 2, 1, 3, 6, 3, 7. And before we have 6, 6, 7, 7, 4, 3, 5, 6. Okay, so just look at what our type. Okay.
Okay.
And compare it what's on the what's in the slides.
Okay.
So is it the same?
Yeah, it's the same.
Compute the D, that's the difference. DI for me. So it's after minus before. Okay. So the first one give us negative 1. 5 minus 6.
Yes. Negative 1. The next one will give us negative 4. Negative 5. Negative 4. Negative 1.
Hold on, I'm coming.
Okay.
This one is negative 6. So 1 minus 7.
Negative 6.
Then negative 4.
4. Negative 1. 3. Negative 2. And 1.
Okay. So our D bar will be add all the D's and everything.
Okay. You get negative 14.
Yes, negative 14. Divided by n. N is what? 8.
So you get negative 1.75.
That's our D bar.
Yeah.
So easy to find the D minus D bar here.
Okay.
What?
You get 0.75.
0.75 square it.
You get 0.5625.
Okay. Next.
Okay, so negative 4 minus 10.
Move to the third one.
The third one.
Yes.
Okay. So you get negative 4.25.
Okay.
When you square it, you get 18.0625.
Yeah, so when you are squaring a number, you shouldn't get a 0. You shouldn't get negative. Though if it is negative, still after squaring it, you must get what? Positive, because it's gonna get poor. So let's move on the fourth one.
So it will be the same as the second one because it's
Okay.
negative 4.
Negative. Negative 1, 2 will be the first one.
So the next one, you have 4.75. And when you square it, you get 22.5625.
Negative 2.5. Confirm it.
Okay. So yeah, negative 2.5.
You square it, you get 0.0625, right?
Yeah.
This one 2.75. The one.
Okay, I'm checking. 2.75 squared, you get 7.5625.
Okay, so get me the sigma of the last one. Yeah.
Okay.
I think you confirm it, but
I'm on it.
I think
0.0625. I had 59.5001.
And so let's leave it like this.
Okay.
Okay. So now, our LD to this. So 59.5. Otherwise, n minus 1 will be 7. So what will be the answer?
So the answer will be
2.1
2.954.
55.
2.955.
So we have everything now. So let's move on to find our T calculator. So you see that the workload is at this place. With D bar, we got what?
You
Negative
got negative 1.75.
all over LD is what? 2.9155 all over square root of 8. What will be the final?
All over the square root of 8. So you get negative 1.6977.
Negative
1.6977.
77. So let's leave it here. Okay.
Okay.
The critical value is 1.895. So the D is telling us that we should decide with the critical value approach. That one I said we compare T-calc and T-crit. The T-calc is negative 1.6. Now by this one, we need the absolute. We don't pick the negative. So negative 1.698. Then T-crit we got what? 1.895. Don't forget to bring the absolute signs here, because this one was negative. So this one is less than this. What will be the difference?
So you fail to reject H2.
Why?
Because our T critical is greater than our T calculated.
Reject H2. Since heat calc of absolute 1.698 less than what? Equal. What? 5% or S. 5% level of
Significance.
Forget to bring the absolute. E was like, we should decide with our p-value approach.
P-value, yeah.
And that one we compare the p-value and what?
The alpha.
P-value and what? Alpha. Alpha is 0.05. And the p-value, you go and check the absolute, this 1.698 from the table. Then we look at the probability of that.
Okay.
So this one too is one field, so we are picking from this side. Okay, so we come through and search for the number which is close to 1.698.
1.697.
Why is it?
Yeah, 1.697.
Yes. Good. So, or 1.699. You see, they are all under same column. So let's go up this here. So 0.05 and 0.1. Which one are we taking?
You will take 0.05.
0.05 because it's what? 1 field.
Yeah.
This one to 0.05. Now with this, you have to be the decision because they are equal.
Yeah.
You don't take what that's the way and yes, they are equal. So which one will be the decision? Because the decision was like if the p-value is great less than alpha, that one you reject. Or that what we have under p-value. Yes, if p-value is less than alpha, reject. So with this one, are you rejecting or you are failing to reject?
So are you
Should I come in?
yeah, come in. I think you feel to reject, but I don't have a reason to come in.
Yes. This one you're being lucky. Okay. So you are failing to reject because the rule is saying that when p-value, we should reject when p-value is less than what? Alpha. But here in the case, the p-value is equal to the alpha. So how can you tell me it's less than 5?
Okay.
5 is equal to 5. How can you tell me 5 here is actually less than 5 or is greater than 5? No, they are equal. But the rule is saying that if 5 is less than 6, then you should reject. But this one, they are equal. So you fail to reject because it's not matching with the rule. Okay. So the decision will be fail to reject. Since p-value is equal to the alpha. Okay. Then the last one will come. What's the last question here? The question was okay, we are done with the F. Did the fitness program reduce absenteeism at 5%? Conclude practically. So I said this is where you use the HO and the HA to decide your answer. So if you don't understand the particular hypothesis that you formulated, that you can't solve the last question. Okay, so I'm asking you the F. So what will be the conclusion?
To me,
first of all,
okay, your answer.
Yes. Okay. Then you give your suggestions. First of all, you look at HO. What is HO saying? What is HA saying? HO is saying that program did not reduce absenteeism, right?
Yes.
And the HA is saying it reduced the absenteeism. And the decision is saying that you should fail to reject what HO.
HO.
If you are failing to reject HO, then HO is true, right?
Yes. Yeah.
The program the manager implemented did not reduce any absenteeism. So now there were absenteeism. You get it?
Yeah. Yeah.
So the conclusion would be what?
The program did not reduce
Yes.
absenteeism.
So there is not enough evidence that the program reduced absenteeism. Instead, absenteeism has increased or continued. You get it?
Yeah.
So that will be your answer for F. So you have to understand the hypothetical formulators. So it will be instead absenteeism increase or continue. You get it?
Yes.
Okay. So let's solve the last question. Then we are done for the day. The question. I copy the question. Let me share it for you to read. Okay. So this is the question. Read it.
Upemu Fitness Center, through their adverts, claim that completing their diet course will result in losing weight. Please scroll up, scroll up. A random sample of recent participants showed the following weight before and after completing course. Use the 5% significance level. A. State the null and alternate hypothesis.
It's always the same questions, right?
Yeah.
Yes. So with the D, you see, they are acting as a non-parametric analog of test statistics. So this one is dependent, right? So under dependent, what's the opposite of it? I mean, the non-parametric of the parametric test. So that's the P test. So with that one, we refer to the slide. So let's solve the rest. With this question, before you know your decision, I have been telling you to look at your UB and UA. So here, Ogulufon, they are saying that Optimum Fitness Center advert, through their advert, claim that completing their diet course will result in what? Losing weight. Mere diet course, after completing it, you lose weight. And someone wants to lose weight. Now here, so we want to test whether those who are involved in this particular course reduce weight, lost weight, or did not lose weight. It will be mu B, that's the mu before and after. So what's the relationship between mu before and mu after?
So far, to me, I think since they are saying after completing their diet course, it will result in losing weight. I think UA is less than UB.
And I said always take it from the B perspective. So UB first.
So therefore, UB is greater than UA.
So you identify your sign. And your sign, which one does it relate to, null or alternate?
Alternates.
Good, perfect. So with this one, your HO, so with the A, HO is such that H is also such that in D. And I said after identifying your sign with the help of mu B and mu A, the rest is mu D and 0. So I think the claim is for or thing that is the greater 0. And if this is greater than 0, this will be what? Less than or equal to 0. You get it?
Yeah.
B. As you have been doing it, T critical. So this one is degrees of freedom and what? Alpha. So the degrees of freedom
Alpha.
is what?
N minus 1. So N minus 1.
1, 2, 3, 4, 5, 6, 7, 8. So they are 8. 8 minus 1 give us 7.
Yeah.
Seven, and the level of significance was 0.05.
Yeah.
So this one is the same as the one we did.
The previous one. Yeah.
Yes, the same as this. 7 0.05. So that is what? 1.895.
895.
Then C is talking about the calculated of test accuracy. So T calc. So this is where the workload is, as I've been saying it. So it's B bar all over S B or square root of what? N. And you know, B bar is also giving us DI, summation of DI all over N. But then SD, the square root of summation
to bracket D minus D bar all squared all over N minus 1.
Okay. So let's write down our table. So after the table, they will give you before comes after. But when you are solving it, just bring after first, so that when you are subtracting to get D, you not get confused. So the after we have 154. And then before taking that course, these are the results.
Okay.
1.5. Now, looking at before and after, can you tell me something? Did they lose weight or they didn't lose? They lost the weight they are talking about, or
so from the table given, it seems they lost weight.
they lost weight, right?
Yeah.
So okay. Let's see how the test will tell us.
Okay.
Okay, so D, so as you have been doing it, so you get -1.
Negative 21. Negative 21. Negative
6.
6. Sorry, 6.
-5.
And you'll be having 5. Negative 5.
-15. -14. 170. This one to I think negative 14. Yes. Negative 7. The di minus d r. Then di minus d bar all squared. So work out for that. When I'm ready, you mentioned them to me.
So you have to find the d bar first. So the summation for the di is negative 71.
Okay, so here negative 71 over n. N was what? 8.
Which will give us negative 8.875.
Yes. Yes,
Negative 8.875.
8.875.
Yes.
75. Let's run it to 2 decimal places.
So 8.888.
Okay. And solve for this one.
So the first one will be 9.88.
Negative 9 or positive.
Positive. I got positive answer.
Is it 9 or 7.8?
No, it's negative.
No, the di one is 7.88. Positive. This one is positive. Check it
So
again.
you get 7.88.
Yes.
Which 8 squared will give you 62.0944.
So let's leave it at 2 decimal places. It's 2.09.
09. Okay, so
Give it 12 points. Find a e for me. Find a square. Give it 12 points.
146.89.
Okay. Down to 3.88. Find 8 square for me. Sorry, it's 14.88. 8 squared will be
14.340. Okay.
14.88.
So you get 221.41.
This one will be 3.88. Find the square.
12.88. So 15.05.
Negative 15, you are getting negative 6.12. Great.
You get 37.45.
So this one, you are getting negative 5.12. Squaring it, we get
26.21.
Good for that of 7, negative 7. It will be 1.88. Find a square of 1.88.
1.88. So 3.53.
All right. Sigma D minus D bars all squared. How will be the summation?
I'm on it. I had 538.84.
You had what?
538.84.
Okay. So now you know this, you can move on to solve our SD. 5, 3, 8. Punch it. N is 8 minus 1 will be 7. So that will be our SD.
You get 8.77.
All right. So you see, this is where we have the workload. Yes, T calculated. So T calc is equal to D bar is negative 8.88 all over SD. SD is 8.77 all over square root of n. That will give us
Negative 2.86.
negative 2.864. Let's add it because the vertical was in third decimal place. So if this one is negative, the absolute will be what?
2.864.
The D was like.
Come again, you said?
D. Can you see the D now?
Okay, yeah, I can see it now.
What is the non-parametric analog of the test statistic?
Test statistic computed.
So with this one, it is talking about this. The table I said is very important, so learn it off head.
Okay.
So this one we are doing what? Which one are we doing now? Pair test, right?
Pair test, yeah.
So pair test. So it's non-parametric is what? We're causing sign rank test or means chi-square test. So let's use the first one. So it's what? We're causing sign rank test. So this should be your answers. So the question was like the analog of the test statistic computed, and that one too, it was dependent. 2 samples. You did it. You was talking about what? We should decide with what critical value approach. That one we compare the T calc and what T critical. T calc is absolute of what?
2.864.
And this one was
1.895.
So this one is bigger than this, right?
Yeah.
So what will be the decision?
You reject each O.
Reject each O. since T cut off as 2.864 greater than what? T critics of 1.895. Okay. So when we are to use p-value approach, you compare what? P-value and alpha.
Alpha.
So p-value, what do you use to check? How do you get out?
Calculated.
Yes, you said
You find the probability of the T calculated.
Exactly. The alpha was 0.05.
Yeah.
P-value, we got 2.864. We take the absolute. So let's search for the probability of 2 points. Okay. 2.86. Which number is closer to that?
The University of Ghana is blocking 10, so 2.86. Okay, so 2.861. I'll say 2.861.
Where is it?
Yeah, go top 2.861.
So it's under what?
0.005.
0.005. There's one tail, so 0.005. This one is less. So it's the same decision, right?
Yeah, you reject each row.
It's p-value. It's actually less than alpha. Level of significance. Okay. And what is the last question saying? Jane, have the participants lost weight at the 5% significance level? Conclude practically. So practically means you must use the one you formulated, the hypothesis you formulated to solve for that. So they are asking you. Now you look at your decision. Decision was what? You should reject H, right?
Yeah.
And what was HA saying? And what was HO saying? So the HO was saying that participants did not lose weight because their before is less than or equal to what? The after. That's the HO here. And the HA actually formulated, we say that before will be greater than what? After. So here, their before was better or the after was less than what before. It means they really lost weight. Okay. But with the HO, they are saying that the participant did not lose weight because the before was not greater than the after. It was less than or equal to the after. It means they did not lose weight. And the decision is trying to tell us we should reject HO. So it means we are going for HA. Do you get what I'm trying to say?
Yeah, I get you.
So it means that since HO is rejected, participants lost weight. You get it? That'll be your conclusion. Do you get it?
Yes, please, I get it.
Since HO is rejected, because HO was like participant did not lose weight, and HO is participant lost weight. At 5% significance level. Or you can say that there is enough evidence to say there's enough evidence that participants lost weight at 5% level of significance. Okay, so do you have any questions?
No, please. No,
Okay,
please.
so thank
Everything
you
is
for the
well.
time. We are done for the day. And we are left with 4 topics. Then we are done with the research method, the quantitative part. So I'm only teaching the quantitative. The qualitative, I'm urging you all to read it on your own back, because that is more of reading. But the next time we meet, we are going to the independent sample. So that one, we are not treating the parametric test, which is the independent. We are rather treating the non-parametric test. That's the man-Whitney something. Yes, we are treating that one next time we meet. So after treating man-Whitney's something test, you treat ANOVA, correlation, and regression. So we are left with 4 topics.
Okay.
So thank you for your time, and hope to see you in the next session. So don't forget, our viewers, please don't forget to subscribe, like, comment,
very necessary.
Share for this channel. Okay, so share for us, like this channel for us, subscribe. Please, our subscribers are very, very low. Because looking at the viewers, the subscribers are very, very low. Please and please subscribe for me. Just click on the subscribe so that whenever I release a new video, you get what notification. Okay, thank you for the time. Bye bye.
Bye.